Okay, we're going to do dimensional analysis problems 126 to 129 on page 8 in your physics manual. If you've already done these, hopefully you can use this to check your answers. Okay, so the first one we're going to do is problem 1.26. We've actually already done this in class. This is converting densities that you used in chemistry, like for water, 1 gram per milliliter. And we want to convert it into kilograms per cubic meters, or it says the proper MKS units, which of course would be kilograms per cubic meters, what we want to be in. Okay, so the first thing we'll look at is the grams. So I don't want grams, so I put that on the bottom, 1,000 grams, 1 kilogram on the top. You need to know your metric system for this next test. Aha, I found you, kilograms. We're good. Milliliter, 1 milliliter is the same thing as 1 cubic centimeter. Those are the exact same things. So that was kind of a wasted conversion factor that I just did there. And then I put centimeters cubed on the top, and I put meters cubed on the bottom. And I need to put in my numbers. And so this is confusing here to some people. There are 100 centimeters in a meter. Most people know that. But these are not centimeters and meters. These right here, these units are centimeters cubed and meters cubed. So what do? Well, that means I need to do is I need to actually cube this 100. If you don't understand why, you can look at a cube here, a 1 by 1 by, let's say it's a 1 by 1 by 1 meter. So 1 times 1 times 1 meter times meter times meter is 1 cubic meter, 1 cubic meter. If I want to know how many cubic centimeters that is, I'd have to convert all three sides to centimeters, so it'd be 100 by 100 by 100, or 100 cubed centimeters cubed. That's why you need to cube that number whenever you have these cubic lengths or volumes here. You have to always cube that number there. It's going to be important to remember that. So centimeters cubed cancel. Aha, I found you. We're in kilograms over cubic meters. 100 cubed is 1,000,000. I can write that as 1e6. 1,000 I can write as 1e3. If I divide 1e6 by 1e3, you subtract the exponents and you get a 1e3. So I'll cross those out. You get a 1e3. And that's the number I have. Times 1 should be 1,000 kilograms per cubic meter is the density of water in MKS units. Next problem, we're going to do 1.27. 1.27. It says a bottle known as a Magnum contains a volume of 1.5 liters. Okay, so 1 Magnum equals 1.5. I'm going to write down these conversion factors, liters. A bottle known as a Jeroboam, 1 Jeroboam, equals 0.792 gallons. Okay. How many magnums, it says, are there in 1 Jeroboam? There's another one. It says 1 gallon equals 3.79 liters. There's all my conversion factors I can use. So it says, how many magnums are there in 1 Jeroboam? So we're going to start our dimensional analysis with 1 Jeroboam. Okay, 1 Jeroboam. So I don't want Jeroboams. I want magnums. But I have no conversion from Jeroboams to magnums. I do have a conversion from Jeroboams to gallons, so I'm going to use that one. 0.792 gallons. Jeroboams cancel. I don't want gallons, so I'm going to put that on the bottom. There we go. 1 gallon is 3.79 liters. Cross the gallons out. Don't cross the number out. And now I'm in liters, and I can use this one. I can do 1.5 liters is 1 magnum. Liters cancel. Aha, I found you. And all we have to do now is the math. It'd be 0.792 times 3.79. And divide that whole thing by 1.5, and that'll be in magnums. Looks like it's going to be probably 2 sig figs because of this 1.5 liters. Okay, you don't have to worry about the 1 Jeroboam. I wrote that out. It's like a perfect Jeroboam, so you don't have to worry about that one. 2 sig figs on that one. Okay, next problem. 1.28. Okay, here we go. Convert the speed of 54.8 kilometers per hour into meters per second. Okay. 1 kilometer, 1,000 meters. Aha, I found you. Now we can go back and do the hours. 1 hour is, and this is where, if you're not good at this yet, you'll probably split this up. You might do 1 hour is 60 minutes, but then you're going to have to do another 1 minute is 60 seconds. What I like to do is just go straight to seconds. 1 hour is 60 times 60, 3,600 seconds. Hours cancel. Aha, I found you. And then I could cross off the 1,000 and the 3,600 and just make this a 3.6. And so I'm going to take 54.8 divided by 3.6, and that's going to give me some answer in meters per second. So we're going to still need 3 sig figs from this thing right here. And now, in the future, if you have something in kilometers per hour and you need to convert to meters per second, just remember, don't do this all the time. Start remembering things, shortcuts. All you got to do, go from kilometers per hour to meters per second, divide it by 3.6. Kind of write that note down somewhere. Divide it by 3.6 and you can convert it into meters per second. I'm going to let you figure out the answers. Okay, last problem. We have a 1.29. 1.29 says the density of a substance is 0.943 kilograms per deciliter. Okay, you got to know your metrics for the test. Okay, what is the density in milligrams per millimeter cubed? All right, we're going to do 1 kilogram. How many milligrams in a kilogram? There's actually a million. 1e6 milligrams. Aha, I found you. And then we want to go to millimeters cubed. So it'd be good to go to centimeters cubed first, which of course is the same thing as a milliliter. So I'm going to do 1 deciliter. 1 deciliter is how many milliliters? Well, a deciliter would be 10 centiliters, and there's 10 milliliters in a centiliter, so 1 deciliter would be 100 milliliters, but the milliliter is also a centimeter cubed. Okay, so deciliters cancel. Then I can put centimeters cubed on the top. I can put meters cubed. Is it meters, right? Oh, no, it's millimeters cubed on the bottom. And there are 10 millimeters in a centimeter. But if you remember from the problem we did earlier, these are cubic lengths, so I need to cube that 10. Okay, so 10 cubed is 1,000, and 1,000 times 100 is 100,000, or 1e5. And you have 1e6 divided by 1e5, that would be 1e1, which of course is 10. So all you have to do is take 10 times 0.943, and you'll have your answer, and you need to keep that in 3 sig figs as well. Okay, hopefully those are 4-dimensional analysis problems. Hopefully you got them all right before you even watch this video. So you're going to do great on the Jedi trial.